We're going to start out hooking the meter up correctly. We're going to put the black lead into the jack on the bottom of this Fluke 233 that says common, and the red lead is going to go into the jack that says volts or ohms. Also do temperature, capacitance, and continuity test. Now on the board, well, before we go to the board, let's turn the meter on. We're going to measure volts. We'll measure volts DC, and we'll go ahead and turn our backlighting on so you can see it better. So we're 0.00. By the way, the meter, as you see, sometimes fluctuate. That's called digit rattle, and that's due oftentimes to what the leads may be picking up from RFI, EMI in the building where you're working. So fluorescent lights, mercury, sodium lights, whatever. So what we're going to do is hook up our negative lead first to the chassis ground of the vehicle. That'll be represented by this braided ground strap on this white background. Now I've got my red lead ready to go on checking anything positive or negative. We're going to talk about both in this little segment here. First off, I notice I've got a switch in series with my power source. So there's my power source, a fuse, and then it branches out and it goes two places. So you might say these two orange wires, power feeds, are in parallel. One goes to these two lights, these two 194 bulbs, in parallel, and the other orange wire goes to this brake light switch. Now if you're a detail expert out there and you recognize a brake switch off of a GM vehicle, normally the brake switch wires would be down here on this end, and when the brake pedal is depressed, that's when this pops out. But for the sake of this little setup, I've actually reversed the brake light switch contacts with the cruise control contacts, which normally are open when the brake pedal is depressed. So I actually want the bulb to come on when I push the button, so I just hooked it up differently. Actually, we'll go ahead and use an ohm meter on this switch later. We push the button in and these two contacts will be connected. Right now there's an open circuit to the bright element of this 1157 bulb, dual element bulb. When I push the button in, I will make a complete circuit between the orange wire contact and the green contact. So it'll be closing the switch here. So right now I have an open to that brighter of the two elements in my dual element bulb. Push the button in and close the switch, and you see my 1157 bulb gets really bright. So that'd be simulating what you're doing when you push the brake pedal to make the brakes. We have basically tail lights right now, some marker lamps and a tail light, and then we hit the brakes. We've got brake lights. All right, let's go ahead, and before we do an experiment with some problems with this vehicle, let's go ahead and see what it looks like working properly. And that's the best thing to do, getting experience on electrical systems or anything for that matter. Always look to see what things look like when the car is working correctly. We'll go ahead and go back to our board now. And let's see. There's our power source of ground. Here's our power source of power. We'll go ahead and look at the meter right here where I've connected my power source into the input of the fuse. 11.73, 11.74 volts. This battery is definitely in need of a charge. All right, now let's go ahead and move our meter lead to the first point where we can probe on the fuse. 30 amp fuse, a bit overkill for this little circuit, but it'll do the job for now. 30 amp fuse, I touch one side of the contact, 11.72 volts. This battery is in need of a charge. And now we go to the other side of the fuse, and 11.71. Now you just saw me use a voltmeter to check both sides of a fuse, the feed side and the side that supplies the power into the circuit. Well, a lot of techs, including myself, would be more in the habit of using a test light. If the light lights on both sides of the fuse is good. If it lights on one side, the source side, but not the other, the feed side, then the fuse has got an open. It's been blown. Now, why would you use a meter? Well, with today's cars, more and more fuses under the hood in places where we might have water intrusion, might not be a bad idea to see if there's corrosion at the fuse. Now, not always do you see a voltage drop. Do you see a difference in voltage between the supply side and the feed side of the fuse? But sometimes you do. So it's worth checking both sides of the fuses to make sure we have the same voltage. tells you you got a good fuse, and it tells you I don't have 11.7 on one side of the fuse, and on the source side I've got, we'll say, 9 volts. That would tell you how to drop a voltage being used by the fuse through a bad connection, a resistance in the actual spade terminals that the fuse pops into. Let's move on down the line to this power source into the switch. Now, to make sure we didn't have a problem between this fuse and this connection and the terminal feeding power to this switch for my brake lights, let's go ahead and probe the feed side of the fuse to the brake lights, and the meter says 1.69 volts, almost 11.7. Now I'm going to move to the next terminal. Now the next terminal shouldn't have any voltage if this is a normally open switch. So what we're reading here is an open circuit at a switch. And the meter shows 007, 0 basically, no voltage. Now, if I push the button in on the switch, watch what the meter does. The light comes on, brake lights, and we have almost 11 volts. So I release the button, and we go back to 0 volts. So we're seeing an open circuit. We're seeing a closed circuit on the feed side of the switch. The source side of the switch is hot all the time. The feed side of the switch, a normally open single pole switch,